This is the video tutorial for lesson 11A.1. This is going to be relations and functions. So just a little warm up here just to practice some of the things that we talked about at the end of last lesson, which is coordinates. So plot the following points on the graph, -6, -4. So this isn't labeled on this graph specifically, but this is our x-axis, the one that goes across here. And this is our y-axis. Now, these points that we see here, the first number relates to the x number, and the second number relates to the y number. So as we're plotting these, -6 means that we go along the x-axis first to where -6 is, which would be here. The second number, -4, means we go down 4 spaces. 1, 2, 3, 4. Now, if I actually plot that point there, notice that if I read up to the x value, it does say -6. And notice that if I read across to the y value, it does say -4. So that's kind of like our little check as we're doing these. But if we're specifically plotting, we should do the x value first. So, oops, let me see if I can put that one back in a little better. Here we go. -2, 0. So I go to -2 on the x-axis. And then 0 means I don't go up any at all. So actually, this is just on the x-axis. -2, 3. So I go across to -2, and then I'm going to go down 3 spaces to here. 0, -1 means that I don't go across any at all, but then I go down 1 space. And notice that you can see here, this is -1 on the y-axis, just as this suggests. 2, 6, go across to 2. And then up to 6. And the last one, 5, -1, go across to 5, down to -1, and that would be our points. And just so you can see a little clearer, because I know that wasn't too clear on the last one, that's where the point should actually be, and you can see the labels that go alongside them as well, just to make sure you got those correct. Now, within this lesson, we're going to look at different ways that you can actually represent data. Specifically, points like this are examples of relations, but there's some specific relations called functions, which is what we're going to focus on in this whole unit. So if we're typing things in like this coordinate here, -6, -4, and I just literally type it in here. And you can see straight away from the table. So the first value is the x value, and the second value is the y value. And I can just do the same for each of those other values as well. I'm using my arrow keys here, and I'm also using my tab key as well. That's another way you can move across, but you can just use the right arrow key as well. And the important part about this unit is recognizing that data can be represented in different ways. So we can have it as a list of coordinates or ordered pairs, as you can see here. These little braces at the start just shows you that this is a group or a set of coordinates that we're using for this question. And the table as well, same sort of thing. It's just 6 coordinates, but it tends to be written vertically. And obviously no commas and no parentheses for this. Mapping. So when we're doing a mapping, this one's a little bit more complicated to do because I have to look at the numbers for the x values, but I have to put them in order first. So I'm just doing a quick check. It looks like my smallest x value here is -6. Looks like my next smallest one is -2. And then I think it's 0, 2, and 5. I think that's good. And then I have to do the same for the y values. So looking quickly across, looks like the smallest one is -4, and then -1. Now, if you have paper, it's easier to cross these out as you're going along, so you can make sure that you don't miss any. Unfortunately, I don't have that on this as an option on this screen. 3 and 6, just making sure I didn't miss any. Well, we will find out in a second if I did actually miss any. So -6 to -4, all we do is we draw an arrow connecting the x value to the y value. -2, 0, I'll go there. -2, 3, 0, -1, 2 to 6, and then 5 to -1. So in reverse, obviously, if you have a mapping, you can just look at the arrows and that will tell you which coordinates there are. So this is clearly -6, -4. I can see there's a -2, 0, and a -2, 3. So the difference between that relation and a function. So a relation is just a list of coordinates, but a function is a set where the ordered pairs where the x values do not repeat. Now, if I go back to my original table here, as I'm looking here, you can see that there's two -2's here. So this is just a relation. It's not actually a function because I have repeated x values. Notice as I was talking about this, I didn't mention the y values at all. So I'm only interested in the x values when I'm looking for these things. And there's examples of all the different ones we did. Graphs, that's what we plotted in our warm-up. Mappings is the one with like the little ovals and then the arrows. And the table and ordered pairs and coordinates we saw as well. And just so you can see them all kind of in one place together, there's our coordinates or ordered pairs, our table, and our mapping. And just so you can see an extra one for mapping. So I put these in order, -1, 0, 2, from here, -1, 0, 2. And then the y values, 1, 3, 4. They're actually already in order, but notice how the arrows go to the same coordinates. So 0, 4, 0 goes to 4, and so on. And then the last one, you can see that you can just plot those points just like you did in our warm-up today. So what we've got to look at is trying to identify a function is one of the important things for this unit because they have specific properties. So notice how we darkened the x coordinates here just to make them stand out a little bit because that's what we're really interested in. And what I'm looking for is, are they all different? And yeah, these are all different. So this is an example of something that is a function. Whereas I look at the second example here, I can see that there's a repeated 2 value here. So for that reason here, these are not functions. So it's fairly easy to tell. It's just making sure you understand those definitions. Now, if we have it as a table, it's as easy as just looking down the x values, and you can see that there are no repeating values here. But if I look on this table here, I can clearly see that there's a repeating 1, and for that reason, this would not be a function. From our mapping, all we look at is the number of arrows leaving each x value. So 1 arrow, 1 arrow, 1 arrow. That means that it's a function. Whereas if I look at the mapping on the right, you can see that there are multiple arrows coming from this number here. And for that reason, this is why this is not a function. So we're only focused on the x values. And for a mapping, that would be your left-hand oval. Identifying functions from a graph. So to do this, we're going to use something called the vertical line test. And the vertical line test states that if a vertical line intersects the graph of the relation more than once, then the relation is not a function. So let's have a look how this actually works then. So I have my graph here. This is really the one I'm looking at. And I've added in a little slider here so we can look. So right now you can see on the graph here that it only intersects the graph once. And wherever you check it, just once. And you kind of just have to check every single point just to make sure it's only one. Now, in theory, what you'll actually do is you'll probably get like your finger up and you'll kind of look at it like that way, or often a pencil is a common method as well to kind of move it along as well. Or if you can draw on a picture, you can certainly draw vertical lines as well and just count. And you're just looking for, does it intersect more than once? So for this one here, it does not. So this one is a function. And if we look on this one here, you can see it goes through just one place, and wherever I draw my line, it's just going to be one place. So this one is also a function. Now this one here, right at this point here, you can see it only goes through at one place. But as I move this to the side here, look what happens now. So you can see it intersects the graph at 1, 2, 3 places. If it happens anywhere on the graph, then we say that this is not a function. So this would be an example of something that's not a function. As I move it further across, it goes back to 1, but that's not important. It's just, is there anywhere on the graph where it goes to more than once? So the key things I'm kind of looking for is, if I'm looking at a graph, is I'm looking for it, does it curve back on itself? Like, does it go to the right and then turn back to the left? So if I see this like S shape, or if I see a C shape as well, something like that, then that's a good indication. Or it could be a backwards C shape as well, but something that curves back on itself is what I'm really looking for. One that's not listed here as well, but we should keep an eye out for, is if they actually literally have, and I'm just going to draw another line in here. Like if this was the question here, is this a function or not? Then a vertical line, it's basically intersects nowhere until the line is exactly on top and you can't even see it now. Vertical line is something that is classed as not a function because actually it intersects at an infinite number of places. Every single point on the line intersects with another point on the original line. So one to keep an eye out for. Now, those are what's called continuous data, as in the line is just joined together. But you can also do these when you just have coordinates as well. So for these coordinates here, let's have a look. That one, you can see it just goes through a single point. And once I get to here, you can see that it goes through 2 points. So if I have coordinates that are directly above each other, then this will be something that's an example of not a function. That point here, it's just 1, but it doesn't matter now because we already know it's not a function. So you only have to prove it for 1 point on the graph to show that it's not a function. And if we look at this one, just 1 point there, just 1 point there, just 1 point there, and just 1 point there. So this one is definitely a function because there aren't 2 x values on the same vertical line. Here's something you would try in class. I'm assuming if you're watching this video, you're probably not in class. So you might want to try these questions yourself, and then you can have a look. Perhaps pause after each one, and then we'll talk through the answers in a second. All right, hopefully you had a little chance to have a try on each of those questions. If necessary, go back and watch the video, just pause the video, come up with your answers, and then we'll take a look to see how you actually did it. So for this first one, this is not a function. As we're looking at the mappings, we're looking at how many arrows come from each x number. So just one. But notice for the 4, you can see 2 arrows. So if it's more than 1, then the answer is no. So this one is not a function. As I'm looking at my x values, I can see I've got 1, 2, 3, and 4, and they're all different. So this is a function. Notice how they tried to put the y values the same, but that's not what we're interested in for this question when we determine if something's a function or not. As I'm looking at these points, I can see it just goes through 1 point here, 1 point, 1 point, and 1 point. So this would be an example of something that is a function. We have one of our continuous graphs here, so I just got to kind of move it across slowly. Just goes through 1 point here. Just goes through 1 point, 1 point. So I can try for all of these, but this one will be good. So this one would be a function. And this is the one that doesn't curve back on itself. Now, if this shape was twisted around sideways, then this would be something that's not a function. So that's the reason that could be put in there to try and see if you recognize that. -6, 5, and 5. Definitely a repeated x value here with the 5. So for that reason, this is not a function. And looking at x values here, so 4, 2, and 5, all different. So this one is a function. Once again, notice they put the y values the same, but we're only interested in x values when we're checking for a function. And then we have some similar questions here. I put in the little slider so you can have a little check to see if you can figure out this one. So this one is a function. Wherever I put the line, it just goes through at 1 point, and that would be good. Let's have a look at our x values here. So I'm looking at the 8, the 4, the 6, the 5, and the -6. These all appear to be different. So I'm going to say that yes, that is a function. Didn't put the line in this time because you've got to kind of get used to using it without the line. So I can kind of use my pencil as a line. So if I draw a line here, it's just 1 point, 1 point. Oh, look, I have 2 points here that are on the same line here. So for this one here, I know this one is no. Now I put this here, which actually wasn't very good. But probably more important for Canvas is if you use the plus symbol here, Desmos, I mean, if you click on note, now you can actually write the word in no. So that's a good way of being able to enter things in Desmos and the calculator realize, hey, this is not an equation. This is just something I want to write down. As I look at the picture here, I can see 2 arrows straight away here from the -2. So that one will be a no. And for the last one, part D here, 4, 1, 3, 6, they're all different. So this is yes. Don't get sidetracked by looking at the y values, otherwise you could easily pick the wrong answer. Now, the last 4 questions, the reason they were called A, B, C, D is another way they can ask the question is that they can actually give you 4 questions within 1 question, and you have to select all that apply. So A, we said was, and D, we said was, and then you can check your answer. Now, often on questions where it says select all that apply, it's unlikely just to be one answer. Otherwise, it would just be a straightforward multiple choice question. So when that happens, always look out for it, see if you can find more than one. They could do one, but I think that would be a little sneaky to do that. We're back to our standard question here now. So I have added a little sketch pad on the side here, just so we can actually draw a little bit. So this was slightly different because I got question marks here. Which ordered pair can replace the missing value and create a function? So if it's a function, I know all the x values are different. So right now I have a 3, a 2, a -2, and a -6. And I have to pick one more, but make sure I don't repeat an x value. So answer A obviously has a -6 in it. So for that reason, I don't want to choose that. Otherwise, I've got a repeat value. This second one here, I don't have a 1 right now. So for that reason, I would want to pick that one. Can't pick C because I already have an x value of 2. And I can't pick D because I already have an x value of -2 here. And that looks good for that one. So just a different way of asking that same type of question. Same thing as before. Look at the relation shown in the table, identify an element that could replace the missing value and create a relation that is not a function. So the important thing for this one is no repeat x values. So as long as you pick something besides 3, 5, and 9, well, good. Just make sure that all the values are different. X values are different. Relations G and H are shown. Select an ordered pair to make each statement true. Use the sketchpad to type the ordered pair in the blank. Okay, so relation G represents y as a function of x. If the point with coordinate is something is removed from the relation, then it would be a function. So let's have a look. Right now, this is not a function because of these 2 points are directly above each other. So this one is -3, 1, 2, 3, 4, -3, 4. Let me just write that down here. Oops, not the greatest comma there. And this one is -3, -2. So if I can remove one of those values, then this would actually work. And -3, 2 is one of my -3, 2 is one of my options. So I'm just going to show an arrow to show where that would actually go. Now, as I'm looking at relation H here, I can see that there's 2 arrows coming from the -1 here. So right now, this is not a function for that reason. So if I want to make it a function, I just want 1 arrow coming from the -1. So if I was to remove this arrow from -1, -7, then I'll just have 1 line here. And for that reason, that's why this would be our correct answer this time. Plot 1 additional point so that the resulting relation does not represent a function. Now, this is one of our technology enhanced questions for the SOL. So there's lots of different places, obviously, on the graph where you could put this. The important thing is we want to make sure it fails the vertical line test. So I just need to make sure it's on the same vertical line as one of these points. So you can either go above, that would be a correct answer. You can go below. But now when I draw in my vertical line, notice there will be 2 points or 3, or basically more than 1 is what's important here. So this wouldn't work. You could easily put a dot on any of these lines here. Just make sure that you have 2 dots that are vertically above each other, and that would work. There's a chance for you to give a little opinion about how you felt about today's lesson, how well did you understand it, or if you'd like to ask a specific question, you can do that as well. But that will do it for this video.